There you go, boys. I'm just going to bring you back in almost as seamless as I left.
Did you get a coffee in that time too, then, Adam? Did you get a coffee in that
I've
time
just
too,
got
then,
a bottle
Adam?
of wine.
Oh, lots of people. Oh, lots of people.
Sorry.
Don't forget to stop sharing. Don't forget to stop sharing.
Oh, yeah, that could freak it all out, couldn't it?
Have you stopped sharing on Skype now?
There we go. There we go.
Right. Seamless.
You've finally
Seamless.
done it, guys. You've finally
Perfectly
done it.
seamless, that. Little bit of tips halfway through, but all good. We're there. Hopefully, I'm going to check chat, make sure I can be heard.
I'm actually starting to like that song.
Get out of here. That's just the dog. That's just as you're happy because of the
I was
dog.
just about to say the same thing, John.
I
As I was reading the words, I was just like, you know what? I do like this song.
And since you mentioned the dog, I was going to pop in, but I dare not go near the house now. After the last time I went in. Sorry, guys. For those who don't know, I got a new dog today, and he's in the house. And yeah, I don't know whether it's mayhem in there or not, but last time I went in, everything was cool, and I was shouted at for coming in and exciting him. So
What kind of dog?
I might be sleeping out here tonight.
What type? What kind of dog is it?
Oh, he's quite a big dog.
You're not going to find out, Nathan.
Yeah, that's about all you're going to get out of John.
He's a crossbreed. He's not a pedigree. He's a rescue dog, and he's absolutely beautiful.
Even as Nathan, right? John has a taking the piss name for me, Beulah. But even we're not allowed to know the dog's name, so we're just going to refer to him as Beulah. So yeah, you got more detail than most there, Nathan.
He's got loads of names: Muttley, Beulah, Buddy, Dog. Take your pick. He doesn't have an all caps name, so there's no point.
But you like Adam, so he likes those names.
I'll be back then.
Yeah. Right, let's just hand over to the man. Zach, if you let us know whenever you want out doing,
Yeah, we could.
we'll do it.
I'm ready. I'm ready to roll. Today we're going to be talking about how the eye perceives light, or how I shouldn't say the eyeball, any optical system with a circular aperture will see light and what actually happens along the horizon and why it happens. It's well understood science. It is taught in every first year physics class. It's mostly to do with astronomical observations. That's why they figured all this stuff out. But it also works wherever you're looking at, even along the horizon, even if you're looking down, even if you're inside in a room, this still takes place. It is a fundamental limitation of every lens with a circular aperture. So, could we start with looking at that Harvard document?
Josh, if you share screen, I'll stick it over.
Yeah, give me just half a tick.
Damn, look at us. Getting organised, man.
Get in there.
We
Not
are
quite
getting there. We are getting there. It's taking a while.
Not as slick as Nathan.
Yeah, we'll have to take some lessons. You could write a textbook on that as well.
I get it all from YouTube.
Do we remember?
Isn't YouTube amazing?
Yeah, I think it is.
The new Library of Alexandria.
Until they burn
Video.
it. Well, it's smouldering nicely in the background at the moment on the fringes of the flat Earth.
No, I'm not that
Off screen,
organized.
this looks good. Better pay attention.
Ooh,
This is actually
graphics.
one of the later ones.
All right, yes, I was going to say I'm not quite that organized as to having them in the correct order.
We're looking for the one. Well, we were going to look at the document first, I believe.
Oh, you do want the
Harvard
Rayleigh's criterion? I've got that. Sorry, right there.
Okay.
I've
You
got
got
that on
that
a web page. Yeah. So let me just pull that back.
It's feeling a bit like Jaren on Globebusters when Bob's not around, gotta be honest.
No worries. Hey, if it's that good, we'll be chuffed. So,
Yeah,
thanks for the compliment,
I
mate.
really
No
appreciate-
worries.
There you go. Right, I'll share screams. I'll just share screams with you guys, and you should be able to.
I heard that as sharing screams. Yeah, I think that's about right.
Is that working?
I don't think you've got that just right.
Oh no, you need to. Why do I look at that? I can't see it.
Did we have this problem before, which was why I had we had to upload them to the network, the Iron Realm network?
Welcome to the Iron Realm Media Learn Along With Us episode. See how we cock it up so that you don't.
Yeah, I brought this in for Anthony, the Harvard document, just to show that this is, it's been well understood. You could actually type in just about any college and write in Rayleigh's criterion. That is the actual equation used to calculate for angular resolution limit. And just about every college will have a paper written on this. I can almost guarantee it in their physics department.
Well, I hope what you're about to say, I hope Al's listening and paying attention, because this, I don't know, actually, it might not relate to him at this point. This is getting quite far down the line. It's not Flat Earth 101, is it? It's kind of like intermediate level kind of stuff.
Well, it starts off that way, but when you get down to it, it's really going to be sort of maybe 102. This isn't really, this is kind of the advanced stuff, but I think what Zach is doing is just setting the stage for what's coming down the pike.
Could you scroll down a little bit, Adam?
I can.
There you go. Okay, right where it says comments there.
Yeah.
Rayleigh's criterion is usually applied to circular apertures where the criterion for resolution is when the center of one Airy disk pattern falls on the first minimum of the Airy disk pattern of the second source. The angular separation, radians, is then, that's what the symbol for radians is. And that's the equation right there. Radians equals 1.22 times wavelength of light over diameter of aperture. Very, very, like I said, they teach it in every physics class. Could you go down a little bit more? I think there's a little bit more. Oh, no, that's it. And that's all. I just wanted to show that it is in college papers. It is a real thing. They even show how to set up an experiment to show this right here.
And that's
But I
all
didn't
quite
really want to-
self-explanatory, isn't it?
Yeah.
The diameter is the aperture that it's going through, is that right?
Yes. Now, I didn't bring up a slide for this, but how to find your diameter on, say, your camera. You would take the size of your lens, and then you would divide it by your aperture rating, your f-stop. So that's why, like the Nikons, the P900s, all of them, they have a smaller lens or a smaller sensor, so they can only go up to an 8 f-stop, where many other ones will go up to like 16, 22, things like that, and they can make their aperture even that much smaller. But since we have a smaller sensor on the P900, the aperture, the f-stop only goes down to 8, I believe.
And
That's the max.
essentially putting that in real world language, the diameter would be the size of your pupil, if you're talking
Correct,
about
yeah.
the eye.
Yeah, the aperture is the circular hole that allows a certain amount of light to come in. And on cameras it changes, on your pupil it changes. Telescopes, not so much. They're usually set.
And doesn't this lend sort of credence to why possibly you could see further at night?
Absolutely, because your aperture, your pupil, opens wider at night. It can get up to about 8 millimeters. Whereas if you're inside in a well-lit room, it usually ranges between 4 and 5 millimeters. And then if you're out at the beach on a sunny day and you're trying to focus at something far on the horizon, your pupil actually shrinks to cut out all the other light. and it can get down to about 2.5 millimeters, depending on your eye size and all that kind of different stuff.
And if you're off your head on drugs, then you can see to the end of the world with a
Depending on which drugs you're on, right?
with a 2-inch diameter. Yeah, I'll shut up.
Absolutely. So we're going to get into how we perceive light first. Could you bring up the number 1 slide with the red circular bullseye looking on it?
Is that the one with the airy disc on it?
Yeah. Let me take a look, and there we go. Okay, now this is what a light source looks like on a what are they, a photon collector or whatever they call them. If you shoot a single pin source of light, it will make that Aries disk. Now this is how we see all light. As you can see on the right, it has the point spread function there on the bottom. Now, it almost looks like a drop in the water, doesn't it? But at that X line, right above where it says point spread function, you will not see anything below that X line. The only light that you will ever see are any of the humps that make it over that spot.
And it's called Aries disk because it was discovered by George Airy,
I believe, yes.
the astronomer royal of fame of Airy's failure.
Correct.
Wow.
And the neat part is we've all seen imagine looking at a candle and how you see that glowing, sometimes you'll even see 2 or 3 rings around it, just like we're seeing there. It's the same thing. If you put a point source, or if you're looking at headlights off in the distance, you'll usually see a big round circle around them. That is diffraction. That's what is taking place. Or the Aries disk, is taking place there. Because it appears to us to be a single source of light. And then as the car gets closer, you see the headlights separate, and you'll see 2 large circles around the headlights.
Yep.
Now, can we go to, I forget which one would be next. Do you have them in order, Adam?
Josh is in charge of this because it was beyond my techno.
Incoherent.
Let's see, for... I knew I should have wrote it down. I'm going to go to... Give me 1 sec.
Is it clear so far to everyone? What
So far, so good for me.
Yep.
Go on.
Good stuff.
Okay, yeah, that's it.
That's the right
There
one.
we go. Yeah, number 4.
Yep, got it.
Yeah. Now this one is showing you what the light source kind of looks like as you have 2 light sources there at the bottom, how they're perfectly separated. You have those lights would be perfectly resolved. You'd be able to resolve each of them, and you wouldn't get any diffraction there. Now, as you would move further back, you would see on D there that they start to kind of come together, but as you can see, the 2 maximums are clearly visible. That is the limit right there. That is the angular resolution limit of those 2 light sources. And then as you see to the right, that's what happens when the sources mend together, and you can no longer differentiate from one light source to the other. And they blur together. Can we go to the next one now?
Five.
Yeah. Is that
The clear sky chart.
no, not 5. 7. 7.
Incoherent and coherent light.
Yeah. Now this is actually showing you 2 light sources, how they are perfectly, it's the same as before, but now you get pictures to go with it. You have the two separate light sources. You see them getting closer together and kind of melt. If you turn it sideways, this is what the setting sun kind of looks like.
Yes. This is what
And
you
then
were
there-
showing in the warehouse, weren't you, with the torch?
Yep, this is exactly the same concept. The
Well,
lights start coming.
It's almost what we've been calling the mirror band so far.
Yeah. Absolutely.
Which never stuck. So wait for the real name to come shortly.
Ooh.
Now, if you think about it, when you're looking out, there is a ring around your head, a hula hoop, the kind that you would wiggle around your waist as a child. Think of holding one of those up, or it's attached to your shoulders, and it's up around and wherever you're looking, that is at 21 feet away. The average human eye is a 0.0165 something or other angular resolution limit. And they just say it's 0.02 to round it off. Now at 21 feet, that'll be about 2 millimeters, which is nothing, 2 millimeters blocking your view, no big deal. But then you get up to 3 miles, and if you have it at 0.02 instead of the like you would be squinting, which would be like a 0.038, then you're already talking about over 4.5 feet, almost 5 feet.
That
So if you think about
wouldn't be visible. Is that what you're saying?
Would not be visible. Yeah, you could not distinguish one light from the other at 3 miles away. 5 feet along your horizon that you're looking at would be blurred.
Yeah,
All
so
the
it's
lights
not you can't
held
see,
together.
it's just you can't distinguish anything.
Exactly. It's that diffraction band, you guys call it.
Well, you
Actually,
can't resolve it.
Yeah.
Your eye can't physically resolve it. Is the way.
But if you pull out a bigger lens, like a P900 camera, and now look at it, the whole image will come back into place because you have lowered your angular resolution limit by having a bigger diameter.
Mm-hmm.
Can we go to the next one? Let me see.
Pretty sure I have them numerically.
6, I believe. This is that one you pulled up.
With the apples?
Yeah. This just kind of shows how the human eye works. As the angles enter it, it's really showing you how the angles get smaller as things get away. This is how perspective works and why it works. It's all based on angles. Now the apple is the same size, but as you can see, the angle when it's closer, they're saying is 20 degrees. And then as it gets further away, it turns into, 4 degrees? At 25 centimeters away. Now these are experiments we all can do. And it just shows how perspective works with the human eye. And it's all based on angles. It's pretty simple. Okay, can we go to the next one? No, is it 5? There we go. No, not 5. I think you had it. Yeah, I think you had it. 9. Yeah. Resolution and the Rayleigh criterion. I actually brought this one in after I was going to do the after I plan on doing the Harvard one, or before I plan on doing the Harvard one, just to show the radians equals 1.22 times wavelength of light over diameter. Now, I should have brought something in that explained the 1.22, but I'll explain it to you, and if you don't believe me, you can go look it up. Rayleigh came up with 1.22 to be a perfect nitrogen-oxygen-based atmosphere, because atmospherics play such a huge role in affecting this that they had to only come up with a limit. That's why they don't have a chart for this. They could only make a limit because the atmosphere can affect it so tremendously. So the 1.22 is a oxygen or a nitrogen-oxygen based atmosphere. And now to give you some scale, 1 would be a perfect vacuum, and 1.33 would be considered pure water. distilled water. So it's not like you don't really fiddle with that number too much there. Astronomers and stuff, they'll mess with the little d, the diameter. Okay, we can go to the next one. Two, I believe.
Zach, just be while they right again. So that's numbers not. It's derived as an optical clarity measurement, isn't it? It's
Absolutely.
not. It's
Yeah.
not
It's,
like where we're talking refraction or anything like that. It's to do with the
that's a
optical
nice
clarity of the medium.
Absolutely. That's why it's just it was all done in a lab, and they did it in a nitrogen oxygen based atmosphere with no humidity, no dust, or they try to make it as clean and pure as possible when doing it. That's why it's the limit, because as soon as you start adding more things into it, that angle that is being obscured along your horizon just gets bigger and bigger and bigger. Now this is how atmosphere affects our vision. This is called a meteorological optical range chart. Actually, could we get the other one first? I should have pulled that one. Yeah, right there. Number 3. There we go. This is the meteorological optical range chart. As you can see, it starts off with 0 being dense fog. You can see less than 50 yards. And it goes through all the different ones, and it goes up to exceptionally clear. You can see over 27 miles, I guess, nautical miles. Yeah. Which is about 30 some odd miles. 30, I'm not sure.
Yards, I think it is. 27 yards.
No, look, John,
No,
it switches from yards to nautical miles. After between 3 and 4, it switches to nautical miles.
Okay. Oh, yeah, so it does.
Yeah, and as you can see, I mean, exceptionally clear, you barely ever see that setting. I've been keeping an eye on this stuff. Very clear is rare. You have to have special conditions to get these. This is when you get the exceptional pictures, like that one I got out on Chicago that one day. That was just, I've never, ever seen it like that. And I got very lucky on that one. Okay, can we go to the next one? The next one shows this is what astronomers use right here. You can find these at every observatory, at least I know, in the United States. They have these, they're called astronomical seeing charts. Now it shows you on the left there, if you can see, there are 1, 2, 3, 4, 5, 6, 7 different things that they use. They have 4 for the sky and then 3 for the ground. In the sky, you have your clouds, what they call transparency. Now, seeing, that's the weird one. Seeing is, since the air is a fluid, it's not, there's all kinds of stuff happening in the air. And you have to think of it like running water. When running water isn't moving very fast, you can see pretty well through it. You can see everything happening on the bottom of a very short, shallow river. Now, once it starts picking up and moving faster, you'll notice ripples, and eventually you get to white water where you don't see anything on the bottom. That's what seeing is. It's the movement and fluidity of the air affecting what you can see. And then, of course, darkness, light pollution, things like that. Then on the ground, of course, you have your wind that could mess things up, your humidity, and your temperature. And I didn't bring it in here, but of course, I mean, it's pretty blatantly obvious. The closer you get to the horizon, the more things will be obscured. They won't even take measurements. I believe it's 25 degrees. It might be 30, but they will not collect data while looking through their telescopes at anything below 25 to 30 degrees because they can't count on it as being accurate because the atmosphere is going to affect it that much. Alrighty, can we go to the next one? Yeah, we'll do this one. Okay.
This is where we're at. I don't think there's
Yeah.
many left if that's the case.
Nope, this is it. It's a short presentation. We're not going to get too in depth in anything. Does everybody kind of understand everything so far? Pretty common sense?
Yep.
All right. Now, this is showing your human eye is there on the left. You can't really see the circle, but the center of the cross right there on the left, that's the center of your human eye. All the light is going to come through, and then it is going to crisscross and project onto the sensor in the back of your eye. So everything really looks upside down to us, and our brain flips it back over and corrects it for us. Now, what I've done here, all these lines are the exact same distance apart, and I've made the top further away from the eyeball than the bottom. And then the yellow triangle in the center coming out, the two angles, the angle above and the angle below, that is your angular resolution limit. Now, it will always be equal, above and below your horizon line. Your angular resolution limit will spread evenly, up and down. Now, as you notice, if you can see, I didn't draw that circle very well, but you can tell by just looking at the lines, the angles on the bottom, as you go further and further away, they are closer together than the angles at the top.
Mm-hmm.
You know, now, if we kept drawing these lines and keep going out, as you see, the angles are all getting closer and closer and closer to that angular resolution limit. Now, once all these angles enter that limit, nothing in there can be seen. That whole red line will be gone. Now, the reason buildings disappear and boats and all that stuff bottom first is usually because there's something higher than your eyesight, further away, elevated than your eyesight, than you are from the water. So as you're looking out, the angles at the bottom will converge with the angular resolution limit quicker than the angles at the top, making them disappear first. And it's that simple.
And this is what you're saying is mathematically or
Absolutely
showing that this is why the bottom of things goes before or disappears before the tops of things. Is that right? It's because you what's above the horizon is generally larger than what's below the horizon. Is that something to do with it?
Yeah, absolutely. Correct.
Gotcha.
So every single flat surface, everything will still disappear from the bottom up and look as though it's going over a curve?
As long as the top part is further away from your eye than the bottom. Yeah. Otherwise, if they're equal, it'll kind of just dissolve evenly, and you won't see it all at the same time. You won't have anything up. Now, if you notice, if you were to lower that eyeball, all those angles would get much sharper, like Ranty was doing with his photos. You know, he'd be sitting there looking at a boat, and then he would go down near the water, and the whole bottom of the boat would disappear. That is because it's not curved. It's because those angles there at the bottom have entered the angular resolution limit now.
Brilliant.
Yeah.
And what are we calling this?
This is Airy's diffraction.
Airy's diffraction. It's discovered by Airy's, and it's diffraction. But I said to you, when you told me, I was like, oh God, not diffraction again. And you said there's 6 different types of diffraction or something along those lines. Can you explain that? Right. Because,
well, it has to do with the circuit. Some happen on the outer edge of the circular aperture. Others happen on the inside edge of the circular aperture. Some happen when you're looking at an object and light is shining over the edge of it. I mean, there's many types of diffraction. It's really interesting, but this one, Airy's diffraction, is when you're focusing on something, it's going to be right in the center of what you're viewing. That's why I believe when Ranty had some of those where he pointed his camera up and the center of the building, the bottom was all clear and you could see them really well, but the center of the building kind of looked distorted there. I believe that's where his angular resolution limit was pointing at. It was up a little bit.
That's really interesting.
Now, the yellow line there, the yellow triangle, it doesn't go off straight like that. The only time it does that is if you have a perfect nitrogen oxygen based atmosphere. So you have to think of it as almost curving. It's going to go out and it's going to curve and open up kind of like a trumpet would at the end.
Sorry, is it inappropriate to ask a couple of questions, or did you want to...
No, shoot away.
Please, yeah.
Okay, the first thing was you said that the angular resolution limit line, I don't know what else to call it, in Ranty's picture was forced up the frame. So correct me if I'm wrong, that proves that he is looking up at those buildings. Am I correct?
Absolutely. Yep.
Yes.
That was
That's
the first.
important.
Okay, the second thing is, on the picture I can see on my Skype page, I hope it's, it is going out to the audience. So if you imagine along, this is going to be a right butchered job in terms of conceptualizing it. If you imagine the very bottom line you've drawn was waves, yeah? And there were...
Oh, yeah, definitely. They would come up and obscure...
Bear with me, because what I'm going to say is, say we draw the waves halfway up that bottom section, so the bottom third, where you've got all those lines going down. Well, if it was halfway up that line, would it reach a point where the wave, because of that angle narrowing, could then intersect the midpoint, or would that never happen?
It could, but it would probably be far off in the distance, unless you were very low to the ground.
Yeah,
then
if
the
you're
waves,
talking
of course,
1
would be
inch.
obscuring. Yeah, the waves could be obscuring it instantly, and you wouldn't even see any of the distortion on the bottom because the waves would be cutting it off. It might even take off some of the top of your angular resolution limit.
That's
you might
kind
be
of
looking straight into a...
If you're standing at the beach and you've got a wave that's, let's make it a bit bigger. Let's make it 3 foot, yeah? And you're holding your camera at 5 foot, yeah? Well, then the first angle is obviously way over the top of the wave. It's nowhere near intersecting the midpoint. But as you go further out into the distance, looking further and further, that wave, which is obviously below you physically right at the shore, is it more likely to dissect the midpoint as you reach the point of convergence?
No, not the one that is very close to you.
No,
it would be a wave. Yeah,
So
it would be a wave.
I mean the waves that are on the far right of this picture.
Oh, yeah, absolutely.
By virtue of it being raised up towards the midpoint, therefore a 2 foot wave, because obviously between you and, let's say, 10 miles out, they're all going to be 2 foot waves. But as you get further out, that 2 foot wave is far more likely to intersect the midpoint because it's further out and been risen up with convergence, correct?
Mm-hmm. Absolutely.
Cool. Because that's another reason why a 2 foot swell can obscure things from the bottom up. It seems like when you've got it in the perspective omitting proof of nothing curve calculator, a 2 foot wave's just a 2 foot wave, but it's a meaningless value when you're looking at things with angles.
And the real interesting part about all this is that no curvature calculator adds angular resolution limit to it. So if you're looking at the horizon and you're seeing up to the edge of the curve, you should have to add the top of the angular resolution limit. You would cut it in half and at least add the top of that to whatever you're looking at off in the distance, which would almost completely negate the whole 7/6R nonsense that they try to throw out.
Explain that again, Zach. Just.
Yeah, go for it. Really dumb.
When you okay, say how they have us looking at the curved Earth, and they always have our eye line up against the curve.
Yeah.
Saying that we're like looking down a little bit.
Yeah.
Well, if we're doing that, they should have to add the little yellow line we see in the center. They would have to add the top part of that at least, the amount that it would be distorted.
Okay, I've got you. Yes,
to the
absolutely.
object off in the distance.
I've got to point this out. That's what they've hijacked. So they've figured out that line is a, let's call it in quotation marks, refraction. and that's the value they take you to, because that is where you're looking. You are looking at the top of the bulge, regardless of how clear the day is. And that top of the bulge, if it's got something you shouldn't be seeing, that's being miraged up 76R, right? When you're in that figure, the refracted figure, the one that's at the horizon, well, then it's sensible to hijack that and put it into an area that you've got highlighted in yellow now that is a band of refraction. It doesn't then matter so long as that figure is a refracted figure and what you're seeing is refraction. It all makes logical sense, right?
Yeah, it's one of the ways they fooled us all.
Yeah, it's how they've swindled it. They've swindled us by getting us to look at a refracted value that sits in an area of angular limitation.
I did a little bit of calculation here. For a angular resolution limit of a human eye that is, I think I did 3 millimeters. It might be 2.5, but an angular eye or something that's looking at miles away. I started at 3 miles. I did 3, 5, 10, 20, and 40 miles. Just showing that with the angular resolution limit, like if you're squinting, looking at the horizon, trying to block out as much of the extra light as you can, at 3 miles, it would already be 9.68 feet that you could not make out along the horizon. So if there was a boat, and you're 6 foot up and you're looking at a boat 3 miles away and you're catching it right on the curve where they say the curve would be, you still should not make out 4.5 feet at least of the bottom of that boat.
Zach, how do you work that out? I mean, is that an easy calculation? Could you off the cuff do 30 miles?
Yeah, 30 miles. Oh, let's see.
Sorry.
No, I didn't do 30. It shouldn't be too hard though. Let's see. 5 miles is 16.1 feet. 10 miles is 35.6 feet. Isn't that interesting? Because at 10 miles at 5 feet up, they say there's 35 feet of blockage on the other shore.
Are you giving us the refracted hidden figures by any chance?
Yeah, that was the or no, 10 miles, 35 feet. This is all at 5 feet off the water as well. These are the angular resolution limit only right here. This is the minimum that will be blocked. 20 miles, 64 feet. You're not going to make out along your horizon. Leave limit. So it only goes up when you start adding particulates, moisture, humidity, all kinds of stuff like that into the air. It just gets bigger and bigger.
The only reason I ask is because I've my personal experience of seeing the Isle of Portland from Seaton 30 miles away, and I know the Isle of Portland. Well, I don't know, but the Isle of Portland is purported to be just under 500 foot tall. But there is, on the day that I went, there is a band running along the horizon that obscures a certain part of it. Now, some people are saying, yeah, that's obscuring, 480 foot, and all you're seeing is 20 foot or whatever, and that to me is just ludicrous. But yeah, just to get a ballpark on 30 miles away as to what would be hidden would be quite cool to measure it up against.
I believe it's right around 90.
Okay. 90 foot. Yeah, that sounds about right.
Have you got more slides to go? I'm itching to congratulate you.
That was it. That was the.
Well, I want to ask a question as well.
Absolutely fantastic demonstration. This is superb, Zach. If you can, I'd love you to present it on the debate at some point. I'd make a big space for you. But that was glorious. I'm smiling here to
everybody understood.
So many questions.
Understandable to everybody.
I concur. I think it's awesome. I mean, it blew me away on Wednesday, and Adam's stuff blew me away even more. It is equally as much. I mean, it's we're getting onto that, aren't we, Adam?
No, not tonight. Don't worry about that. It's just.
Hey, Tony, you said you had some questions?
This is.
Yeah. Zach, are you familiar with the phrase Poisson's spot?
No.
Poisson spot is an issue that I don't know what the answer is, but it's basically where a spherical object passes in between a light source and a wall that you would cast the shadow onto. So in other words, you've got a light, i.e. the sun, casting light onto a canvas, i.e. the earth, and if the moon passes in front of it, moon spherical, a Poisson's spot should be formed on the earth. Now, obviously, they tell us that there's a path where the moon passes, like as the moon passes in front of the sun, it creates the path of totality. But Poisson's spot is a small dot in the middle of the path of totality, where for some reason light is emanated or concentrated or focused in on that little spot in the middle. And the best way to describe it is if you threw a dart into a dartboard and got it bang in the middle, the little hole that it would create is like the Poisson spot, but it's a focal point of light. And the bizarre thing about it is, for some reason, they say that it's due to Fresnel diffraction, but somehow there can be a shadow of a circular object, and in the middle of the shadow should be this Poisson spot, which is the focal point for Fresnel diffraction. And because of that concept or that phenomena, what it means, I know this is a little bit off topic, but in the context of diffraction, it's there. We should see when there's a solar eclipse, we should see a Poisson spot in the middle of totality, the path of totality, and we don't seem to see it, and it's just bizarre. Yeah, you can see it on the screen now. So if you look at the diagram on row 3, or the top row, top left hand corner, you've got like the projector light, and you've got the moon in the middle between the target and casting the shadow onto the canvas. Poisson spot sits right in the middle, and for some reason it puts light there due to Fresnel diffraction. But we don't see it when the moon passes in front of the light from the sun. But there should be a Poisson spot there, and it's caused by diffraction. And now I'm not.
I am going to experiment with this because I think I've created this already when I was playing with shadows and how I could make shadows smaller and bigger using Fresnel lenses. I believe I have seen this already. I'm gonna have to go back and look at my videos. If not, I'll set it up again, and I'm gonna make this.
And it's interesting you say that, Tony, is that we don't see it in. You're talking about a solar eclipse, right?
Sure.
And there's numerous other phenomena we don't see in a solar eclipse, like, for example, I mean,
an umbra and a penumbra,
and things like we've had. Not just cameras pointed at the sun, other equipment like solar thermal cameras and things like this pointed at the sun, and it just doesn't seem to be a moon going in front of it.
I totally agree. I argued that point and I got ridiculed by the ballers, but it's called all the photography guys are all trying to capture Earthshine, which is obviously the bouncing of light off Earth back onto the moon and then the camera lens picking it up. And it's called the holy grail of photography because it can't be done, apparently. It's so difficult to get, right? But it's almost like chasing unobtainium. It's like the question isn't so much can it be caught, the question is so much like have they caught it or who's ever caught it. The question is can it be caught? Because I agree with you. Everything that I looked into on that solar eclipse.
Yeah, I don't think I've ever seen anybody with a real one.
The only person.
I was going to say, moonshine's easy. You just get a copy of Photoshop.
Well, yeah, I mean, the only person that caught evidence of Earthshine was Soundly, right?
Exactly. Say no more.
All the astronomical societies all around the world were all trying to get the same thing, right? We had a guy from somewhere Blackburn way, Lancashire way. It's called Stephen Cheatley that flew out to America with all of his equipment, and he wasn't trying to get Earthshine as far as I can tell because of the camera settings that he had. Because apparently, according to one of the ball earthers, he had his camera set up on ISO 400, which according to them would be nowhere near strong enough to capture Earthshine. But then, when you check what camera settings were set up on this camera at the time, he had 400, ISO 400. So it was impossible that he could have caught it the way that he did. Apparently he overexposed it and done some trickery that all the astronomical societies and the photographic societies weren't able to do, and they've all been doing it for years, and nobody's ever caught it because it's called the Holy Grail of, and obviously the Holy Grail is basically nobody can ever capture it, right? But
And I'm
not
pretty
all of these
sure. I'm pretty sure that Soundly's photos were, in quotation marks, obviously, were taken apart and shown to be highly anomalous. Was that on
Yeah.
Globebusters or
Well,
Paul on the Plane or something?
There was me, Chris Monk Selly, and Mike Helmick. By independent research, we were all working on what Soundly had done, because we realised that there was no way that this guy's got what he's claiming. And when we realised that there were other people that were doing it, we all got together and basically said to each other, right, what did you get? And the answer was, there was no evidence, because what we did was we were in Sun and Moon Group at the time, and we asked people to, wherever you were in America, take your pictures, send them to us, and let's collate them all and let's go through them with some element of forensic attack, see if we could scrutinize and challenge everybody's pictures to see was there any evidence whatsoever of the moon being there. Because the claim was, or the projection was, we don't think the moon passes in front of the sun. We think it might go behind. And we're trying to establish, is there any evidence to support the idea that the moon passes in front of the sun? And we got nothing, absolutely nothing from. There was about 150 photos. I could link you the Google Drive, and you can look through them yourself. There's no evidence whatsoever of any of them. Now it was about 35 people all over America with different cameras, with different settings, with different positions and different everything. Not one person got any evidence of the moon passing in front of it, right?
Except Soundly.
Yeah, of course, but that doesn't mean that it didn't pass in front of it. But it means that when Soundly claims that Earthshine, he managed to get it right. Now, bearing in mind, he actually told us at the time that he didn't have enough space on his SD card to do any long exposures or to do anything more than basic rudimentary photographs, right? And that was his reason for why he didn't get certain photos. But 2 weeks later, and Bob from Globebusters he's the witness to it. 2 weeks later, he turns up with photos from the totality point, and I'm like, you told us 2 weeks ago that you didn't have enough of a SD card space on your SD card to take these photos. So why is it you've now turned up with them? And he honestly, well, I don't know whether he honestly forgot about it or whether he deliberately deceived, but point was he told us he didn't even take them. But 2 weeks later, he releases a video saying that was exactly one of his intentions, to try and capture Earthshine. And I'm like, hang on a minute, you told us 2 weeks ago that you didn't have enough space on your card. So that's complete nonsense. And he's faked it. Honestly, he's the dodgiest person in Ball Earth, but he never gets challenged on it by the ballers. They all think he's wonderful, and I'm like, really? Do you not see the problem with this? At 16 miles, you've got your Pontchartrain showing more curve than a basketball, and then Ranty's got 18-mile observations, very similar mileage, and he's got it flat as a pancake. So it should be consistent, right? We should see similarities between the pictures, and we shouldn't have straight lines on Ranty's if we've got this bendy line that's got like a basketball on Soundly's. It cannot be. Soundly should be getting the same as Ranty. Ranty should be getting the same as Soundly, and we're not getting it. So something's not right.
With regards to Ranty's work, right, on what Zach was saying, Nathan, it was one of the first things Nathan said. In terms of what Zach was saying, in terms of Ranty's stuff being proven to be angled upwards, Zach, can you just fill on that? Because that's I think that's, if that can be demonstrated optically, that pictures of Ranty's are angled upwards, because you can demonstrate what the zone is in the image, and therefore demonstrate it's being angled up. That really is a proper ball killer, isn't it?
This is why astronomers were the ones who developed this, because they're always looking up, and that wherever they're pointed, they did it so they could tell how well they could resolve two stars that were close together. So as they point there and they aim it at one star, that angular resolution limit in the center may make two stars become one. Now, so wherever you're pointing it at, that's where the obscurity is going to be. Wherever your eye is focused at, that's where the angular resolution limit is going to happen. So in his picture, as he looked up, all the angles on the bottom became larger now, because he was raising up that angular resolution limit. So all those angles at the bottom started getting bigger which allowed him to see more along the bottom. But you could see in the center of his picture, the buildings, they went straight, and then they got kind of wavy, and then they went straight again. And that is where that band of diffraction took place. Is that understandable?
Yep,
Yeah.
perfectly.
Good. Yeah, it's like I said, they've done such a good job at making the curve based on this, like almost based on our vision.
Yeah.
Right, so
It's reverse engineering, isn't it, Zach?
Yeah.
I reckon.
What's this? What's the crack with this curvilinear perspective? Have you come across that, Zach?
Curved linear perspective.
Basically, it's the idea of turning a normal photograph. Imagine if you take a normal photograph, but you take it through a glass crystal or a crystal ball that a fortune teller uses. All the straight lines become curves. There's no straight lines in it anymore. Everything's artistically curved. But I've heard one or two people talking about this concept called curvilinear perspective, and our eyeballs are acting like this. And I just thought that's absolutely utter garbage.
No, they do. You see in curved lines. It's just now Gav is going to get into this a lot. Gav and Glenn and Chris, the guys I'm making the Great Switcheroo with and that kind of stuff. Man, they have it all down to a science. And I couldn't even come close to explaining it as well as they do.
the table's the best way, Zach, I think.
Can you shout them out? I mean, have you got YouTube channels for them? Or
Gav, he's the one who's always on Dell's a lot. He has a degree, I believe, in mathematics and physics. And his YouTube channel is Vortex Puppy, all one word, VORTEXPUPPY. Glenn, he doesn't have as many videos and stuff like that, but he does have a YouTube channel. I believe it's Ordic, let me see, I have it written down right here, actually. I don't want to. Yeah, Orbic, ORBIC, Fud Pucker, FUDPUCKER. And then the other, I love that name. And then the
He's
other
a Nordic
gentleman,
Fud Pucker.
yeah.
Love it.
And then the other gentleman, is, of course, is Chris Van Matre. What was that, Josh?
So is there anything like a fig pucker?
Or a fig pucker son.
a pheasant plucker?
And if anybody would like to, I don't know if you've all seen The Great Switcheroo, they get into it a little bit about the gentleman who discovered that we see with a circular eye on a flat plane. His name was Thomas Reed back in 1750. And not till 70 years later did they come up with spherical geometry that was based off of all the work he did. It was actually, what's his name? Gauss and his protege, Riemann, or what's his name? Oh, I forget. Gauss and his protege were the ones in 1820s who switched it all around. They took our eyes that see circular, and we were on a flat plane, so they just switched it. That's why they called it the Great Switcheroo, because they made the plane a curve now, and they try to make us think that we see in a rectilinear fashion.
Brilliant.
Yeah.
So tell me about Thomas Reed. How do I find him? Because there's a lot of names called Thomas Reed. Is it
R-E-I-D? And he wrote, which Gav says is one of the greatest books, and everybody should be made to read it in, grammar school or maybe a little bit up, but it's called An Inquiry into the Human Mind on the Principle of Common Sense. And it is it's kind of hard to read. You might have to read it a few times because they wrote, it's such a beauty. It's like poetry.
Can you say that again, Zach? An inquiry into the human mind
on the principle of common sense.
I have it as a PDF. You can download it as a PDF, which I'll put a link in Skype to. You might want to post that in the main chat so people can see it.
Absolutely.
Have you read it?
Thank you.
No.
No, not yet. I'm looking for a hard copy. And the cheapest one I can find is like $45.
I love reading these old books. It's just there's something about them that is just immense. The way they can put what we say in a paragraph into one sentence so succinctly and fantastically. I mean, we are ultimately dumbed down these days, and you say it might be hard to read, and those are the books I like to read because it makes you, it prompts me to go away and look up the words that I'm reading, because they're forgotten words, most of them, which is half the reason why we can't verbalize what we're trying to say. We're having so much trouble because we were never taught this language. We were never taught this I can't remember what they call it now, nomenclature.
Yeah, this guy was the guy who, okay, Nathan, look at a table in your room and tell me what shape it is. What shape is the table, the top?
Flat.
Well, no,
the shape of the actual table, is it round? Is it
rectangle?
Yeah.
Rectangle.
Is it though?
Now, is the table rectangle or is what you're viewing a rectangle?
Well, no, that's why I went silent, because I was trying to describe my vision.
This is the guy who, this is the guy who distinguished between a tangible object and a perceived object. Because the only way you're going to see it as a rectangle is from 90 degrees up, looking straight down. When we look at it, it's, kind of tilted to the side, and they're all parallel lines, but the angles may be a little different, and this and that. He was the one who said this is a part of perspective that nobody has looked into yet. This is, when you take this into consideration when you're measuring things, you have to take all of this stuff into consideration. You can't go and measure the tangible object and then stand away and think that you can measure it again just by looking at it.
But in a way, this is what Nathan and the crew have been reintroducing is the perspective angle of it. That things get smaller as they go away, which hasn't been included in the Ball Earth propaganda teaching. So it's in a way they're like the rectangle table. It's going to look like an oblong, not an oblong, but what is it? Rhombus.
Zoid or rhombus or something
along those lines, but
trapezoid, or parallelogram.
What angle you're seeing it from.
Well, this is it. It's more to it's a step on from perspective, John, because it's the angular size reduction at distance obviously applies, but what Zach's describing is the viewing angle as opposed to just the angular size reduction at distance.
But I think is it not just the angular? I mean, the fact that when you look at a circular table, it looks like an oblong, and like they say, you can only see a circle when you're 90 degrees above it or perpendicular or whatever. What else is changing other than the angular resolution when you're looking at your viewing angle?
So if you imagine what they've tried to do, or what the path they initially tried to take us down, was to say that if you were standing 90 degrees to these turbines, the center of the hub, you would see them disappearing off in a straight line. Now, that very narrow circumstance is true, but it's the only one where they can have an exclusion of perspective. Now, beyond that point, which is obviously much more akin to reality, you've got not just the fact that the thing's smaller because it's far away. When you're looking at the turbines, are a good example of this. If you're completely level with the bottom of it, say you're 6 foot off the ground, well, you've got a directly straight line to the bottom section, but to the top section, you've got a completely different angle, and it's varied all the way up the length of that wind turbine. Now, if you then take 3 steps to the left, you've completely changed your viewing angle to all of it just by taking 3 steps. But that's the angular size reduction has remained the same. It's still the same size in the distance, but your viewing angle has completely altered your view, in the same way my table will change from being, the line that's closest to me, because the table's offset in my view. The line closest to me on the near edge is almost straight, whereas the angle on the other one is coming in towards a perspective line. So they're completely different angles.
Yeah,
But
I
I
got you.
them to be symmetrical by looking to it 90 degrees. So it's about viewing angle as opposed to just the angular size reduction. I think that's, I hope I've summarized that reasonably well.
No, very well. Yeah, I'll get it.
Yeah, there's so much I still have to learn about all this stuff. But I think we're finally starting to get a grasp on how they tricked us and how it all works, and we're getting there.
The diagrams were brilliant. I mean, I could visualize in those two, I don't know how to describe them, the two nipples that are coming up from the ground. You can see that what you are detailing in that graphic depiction is how those two things merge into one. That is that band. That is precisely what we see.
Yeah, the way I see it is, or the way I envisage it is like the retina on the back of the eye is like a TV screen with pixels, and if you look on a TV screen at 2 points of light, say a car headlights, then it's clearly visible as it's close up. It's clearly visible as two separate lights, but as the car either reverses or you zoom out, then those pixels become closer and closer together until you're left with 2 pixels depicting the two lights, and then it goes just a little bit further where 2 pixels is too much, and it turns into 1 pixel. Is that?
Yeah. Perfect.
Yeah, that's how I see it.
Yeah, angular size limitation.
And there is actually that limitation on our eyes. That from what I read, we see in 1.2 megapixels. The human eye is the equivalent of 1.2 megapixels. So
about
that
a 50 millimeter lens. Sorry.
Right.
Yeah.
But with the paint cans example, when Zach did that, because the camera's essentially a matter of millimeters, the bottom of the lens is millimeters off the ground, that angle is so small that you don't have to go very far back to get this effect. So in other words, this is really, I don't want to say it's easy to replicate in the small scale, that's demeaning what Zach's done, but you can replicate this in the small scale relatively easily by getting your camera very, very close to the ground. And therefore you shorten that lower angle.
It was done by Phuket Word with the cigarette lighter across the park. He had it on a perfectly level concrete play area. Does anyone remember that?
I don't think I've seen that one.
Yeah, that's what gave me my idea. I started mine with a lighter as well, with marks on it.
Right.
That's the very first diffraction test I did.
Right, and he was showing kids sort of wearing flip-flops across the other side of a play area, and their feet were being mirrored. And this was over a space of, say, 50 yards. So, yeah, like you're saying, Nathan, it's absolutely demonstrable, even on a short scale. It doesn't have to be 30 miles, 50 miles, or anything along those lines. It's just a known phenomenon that they clearly knew about and disguised.
Yeah, I mean, the converse, if people were thinking, well, what's the globe side of this argument? When Zach's done it in small scale, there is no difference, relatively speaking, to a big, massive observation over a huge body of water. There's just a camera, a target, and a big expanse. But with the
Taboo,
sorry, go on.
I was just going to say, Taboo Conspiracy actually made a video after I did that one of a sunset that he did, and he showed the pictures were almost exactly alike. My sun setting and a real sun setting.
That's right, side by side, wasn't it?
Yep.
Yeah, fantastic.
So that's the typical flat earthy way of doing things. It's a camera, it's very simple, it's cheap, and that's what we do. Whereas the ballers will say, well, no, what's actually happening is stuff is being refracted back around the curve 76R. And then they'll go to completely wild explanations with liquid butane or heating up the air with 1,000-degree candle flame. You know, they'll try and distort things with these outrageous, and the scale will go down, but the thing that they're manipulating with will go vastly off the charts, you know.
Yeah, nothing that we see in the real world.
Yeah, we don't live in liquid butane, and we don't, you know, we're not all, you know, there isn't a row of 1,000-degree candles between us and our target. You know, it's ludicrous, but that's what they'll do to try and.
The liquid butane one makes me laugh, Nathan, because they show that and they keep getting that little bit of red popping up, but you can see how limited the effect is. If you look at the top of the green thing, that never moves once, even though there is significant cold air from the butane around it, but it doesn't bend that.
It squashes the red plasticine up into the area that was formerly occupied, but the stuff at the top doesn't move a bloody inch. You're right.
And it only
shows how
happens for
extreme
a
it has
split
to be.
second.
Yeah.
It happens for like that. When we see mirages, quotation marks, in real life, that lasts for hours. You know, I don't understand how they can explain that. They say it's a mirage, but yet it doesn't move, and it sits there for hours. No atmosphere anywhere.
Very, very interesting part of the debate, actually, because this is where we get a big win. Because when they model refraction, they're modeling terrestrial refraction, 76R. They've got all their parameters laid down, and it's relatively simple for them to bend in perfect symmetry stuff back around the curve with a ray tracing program or a big CAD or they can go, there you go, there's what it should look like, and it looks just like your photograph. But then when you actually get down to what they've hijacked, the circle of confusion, this band with a fold line running down the middle, exactly like you showed on your paint cans. Oh, no, they can't model that. Actual effects of refraction. I've got to stop calling it. It's not refraction. It's
diffraction.
Sorry, I've got to get the term.
It's on screen now, Nathan.
Aries diffraction, to be precise.
Yeah, because there are 6 different types of diffraction with a circular aperture. So yes, Aries diffraction would be the most precise terminology.
We like precise terminology.
Yes, indeed. So Aries diffraction is your actual culprit, and they're not ever accounting for the effects that it may cause on a particularly clear day if something is at that limit.
Mm-hmm. I've never seen a calculator that applies it.
No, they can't, because what they'd have to do, I mean, well, they may be able to do it, but the mathematics would be immense. It's not something anybody could ever do on a piece of paper on the fly, because you're having to bend a diffraction effect into terrestrial refraction 7.6 around a presupposed radius of an Earth. It gets to the point where it's too challenging to do. And I said this the other day on one of the debates to one of them. I said, you won't ever do it. I think it was Ruhif. You won't ever replicate this.
Yeah, isn't it nice to be able to say that with such authority and know that they can't?
And they won't ever.
So where does this leave us then? What have we taken from this to bring us forward?
Well, we've now demolished the ground-based part of the heliocentric deception. So obviously we talked with the teacher that Anthony was talking to about where his cognition took him immediately when asked for scientific evidence, which is space and the air-based part of the deception. Well, that's been, no offense to all the hard work that's been put into that, but it has been done to death. People have ripped that to shreds. Whereas what you've got in practical terms that you can do on the ground is go to their begging the question proof of nothing perspective omitting curve calculator and put in your observation. And when you do so, what you actually get spat out is perspective. So they've hijacked perspective and called it Earth curve. That's what we've discovered.
And we're showing that it's not perspective, or it is perspective, but it's also angular resolution. It's also all these other factors that they just gloss over. They don't include it.
I think they do include it. So I sound like I've contradicted almost everything you've said tonight, John. I'm really sorry.
It's all right.
They do include it. I think what they've done is they've taken every aspect, not necessarily the last one, which is what Zach's gone through, which is the actual angle of attack or the angle to target, whatever you want to phrase it as. But with the exception of that, because I will detail that as well, and then I'll go on to my point, which is to say that they angle the camera down by essentially anchoring the camera at the target position. You can slide it along in their calculator on the graphical depiction, but ultimately what that's doing is it's anchoring a point that your camera is looking at, and then as you go up in altitude, you'll see that point remains the same. So that's how they've kind of got around that particular detail. So they have kind of included that by just saying, well, no, you're always looking down. You're always looking down at the horizon, and then therefore down at all the stuff that's beyond the curve.
Yeah.
But all of the other aspects do seem to have been, included to a certain degree in the calculations, so they've got all sorts of different areas that they can pick out of the calculator when they need to. So I think they've co-opted many different aspects of it into the calculator, so they've got a sort of one-stop shop best fit for almost every piece of photography that you can try and throw at that calculator. So the win really is that you can point out, and in time I'm sure it will be the case that people will be doing these more complex accounts of what you're seeing and how you're seeing it based on a lot of information, but it will be all encompassing of perspective, certainly not Earth curve, because there isn't any.
Can't wait for those experiments.
Again?
It can only get better. I can't wait for those experiments now, because people are going to get this. Anyone with an open mind and a scientific mind is going to get this and be able to test it. So I can't wait for that.
Indeed. But I think it's
Did you not bite there, Nathan? I thought you was going to bite there.
No,
they were in separate sentences. So
two contradictions one after the other. I think I'll just let that one slide.
What, did I commit a faux pas?
Nothing at all. Absolutely nothing.
It is what they're doing in terms of definition of science and experiments, like what we was talking with John Quantum
right
about this week's sort of stuff.
And you let me up, Adam, you bugger.
I was just surprised you went.
Well, I'll just take it away.
Did I walk into a bear trap? Sorry, I've put my foot in my mouth, haven't I?
Well, I'll just blame someone else. So Rand Campbell, flat out elected, was recently saying, in his way, I won't even try and do the voice, but saying it's all science's fault, and science has lied to us, and these scientists this and all the rest of it, and science is on our side. They don't have scientific evidence for any of this stuff. Science is a very narrow thing, but to give themselves credibility, the people who lie to us, mostly pseudoscientists, they will hijack that term to give themselves more credibility. And I had to pull up Ranty earlier today, and he's saying, oh, I'm going to go out and do this, that, and the other experiment. I'm like, oh, it's not an experiment, Ranty. In fact, it was Ruhif again who called him on it, before he'd finished his breath. I was waiting for a pause in the sentence from Ranty to say, actually, that's not an experiment. And Ruhif did it for me. And I had to agree with him. It's like, well, no, you're just making an observation, Ranty. You're not adhering to the scientific method. So don't hijack that term. You said experiment, John, so that was all it was.
No, I'm more than happy to be pulled up on any faux pas I make, because I just don't have the time to keep up with this stuff. It's changing every day. I mean, it's so fluid. It's unbelievable that you can really make a faux pas from one day to the next. It's great. So yeah, keep correcting me, and I'll more than happily adjust how I talk about things. It's like my phobia against the word gravity.
Planet.
Well, the great thing about this week is all the thinking, and it's gotten me going down so many different rabbit holes looking at this idea, this light, this whole thing. I found a video, I dropped it in the Skype chat, kind of just with what we talked about on our pre-show with the concept about the points of light and what you were talking about with the presentation, Zach. I was trying to find something to kind of tie that together with the split slit experiment and the particle versus waves and how we still really don't even understand what the hell light is, and found this crazy video about somebody doing some experiments with a laser and some nails, and it's pretty interesting what they caught. He's actually, I guess he's still a glober because he goes off into some spacey stuff there at the end, but the images they were able to catch, pretty interesting.
Who's the producer? Who's the videographer?
I'm trying. I think it's the Roger guy from Mud Fossil is who put the video up, but who actually did the experiment. He says it in the video. I don't have it right on the top of my head. I just found this yesterday. While, like I said, our pre-show Wednesday had everybody just blown away with what Zach and Adam were talking about and what they're talking about here. We were just. I went YouTube researching. You know how that is. How you get lost down those rabbit holes real quickly.
Do you want to do that ramble then? Because this is John's mentioned it, and it's nothing special. It's just a little thought I was having.
Absolutely, because it to me fits all this. Because while we're looking at all of this, we still have to understand why this light is doing what it is and what the hell it is. Because what they're telling us it is obviously is a bunch of BS.
I really want you to cover it, Adam, because it kicked me in the nuts big time, and I thought it was absolutely fantastic in the way.
It's not scientific.
I don't care. I don't care. It's testable.
Where's Quantum? I saw he was in chat earlier.
It's testable.
I don't know how I can show it. Josh, how do I show this? I have to go to Skype. That won't work, will it?
To me,
no, I can't do it.
It made sense to the magnetic declinations that you see on maps, and that someone was saying, at certain points, if you look up these magnetic declinations, it will say when you're looking east, you should adjust 180 degrees and say and correct yourself so that you're looking essentially west. And the graphics that you brought up on Wednesday were it was just like it was that game of Tetris again for me.
Right.
Not that you can bring them up now, of course.
No,
we're just teasing.
I can't do it because I've only got one.
Well, here's
PC
the problem.
running.
I just saw a note from Josh. He actually had to step away for a second. So if he's tied into your presentation abilities, then we're kind of tool block.
It's not that, mate. I can't share it whilst streaming the actual show.
How perfectly scripted is this? See, complete
Do I have
suspense.
I'm sorry. I did go to do it and then realised I have no technical capability. There is a way. I'll figure it out for next week. Because
cool.
Sounds good.
How you tease?
I'll show you I'll show you afterwards in the week.
Psy porn.
Yeah.
Well, now I'm happy.
No,
Made happy by Zach tonight, and yeah. Thank you, Zach.
To gain access, all you need to do is become a member of Iron Realm Media.
How do you do that?
Right.
And then you still won't gain access because we're useless.
Then all your tech stops working.
Actually, John, the way you're saying that is a joke. It could actually be happening over there at the website because our wonderful llama friend has been doing some amazing work with our website, getting it up to speed. My goodness, it looks so much better.
Sounds good. Lovely.
It's my pleasure, Nathan. Thank you for being here, really.
Yeah, I love it when things that I keep saying, I don't have no real explanation for this. We'll call it dirty air. And then someone
Right.
like,
Dirty air.
that's brilliant.
Yeah, I knew you guys would get it right off the top. You guys have been doing so much work on this, and then I knew it would click with you guys.
Gonna
That's why I
count the
wanted
name drops next week, Zach. How many times they get in here?
Yeah, and that's one thing. I tried doing it, but my channel it wasn't that big when I was doing it. But I was trying to get out there, Aries diffraction, look into Aries diffraction, and I just couldn't get people to look into it.
Well,
But it's starting.
That's the good thing, isn't it? Right, that's going off now. We're working together. Look at tonight. You know what I mean? Look at what Nathan and Riley kicked off.
I know it. Yeah.
We all had to catch. We had to catch up to use that.
You guys will be past me in no time.
But just to have an expression or a name of Aries diffraction that someone can go, Aries what? And then go away and look it up, and it's actually a thing.
Yeah, I've been
In
told
their
so many
land.
times that I was making it up. There's no such thing as Aries diffraction.
Yeah, the best.
You're making up
best
the
one for a
word
weird name
angular
is,
resolution limit.
the best thing for a weird name is the circle of confusion. It is actually a thing. It's not something we called it.
Yeah, but
Yeah.
now you've got a red nipple paint drop looking thing that proves it's real science, because you don't get them in pseudoscience. That
I
diagram.
still love Dirty Amy.
Hey, as long as you understand how it's happening, I don't care what you call it.
Well, you should really contextualize that because it sounds just like you're a filthy man. I love it, Emmy. Like the stag I do.
It's not just that we can actually describe it in a less dirty old man kind of way, dirty, yeah, but it's actually that demonstration, mate. It was brilliant, and thanks, pal. It going through it, a number of extra bits clicked, as you were talking about, as Nathan mentioned, the viewing. It really does help you understand what we're seeing and why we're seeing what we're seeing with some of the stuff that Ranty's been doing. Shame he's not here. You know what I mean? The work he's done and you guys have put on, it really did help understand that, because it's been bending my head how the hell that 1 foot observation or 1 inch observation was.
I don't know where we're going or whether we've got other people joining us coming on or whatever, but if you guys
No, we're done.
I mean, if Anthony or Nathan want to share screens, if they've got visuals of what Ranty has been doing, then absolutely feel free. It may not work, it probably won't.
No, I can do that.
Okay, that sounds pretty good. I don't know if you guys have got sort of folders of some shots or screenshots or whatever of what Ranty has been doing, but I know for a fact it's some really interesting stuff.
What have you got?
No.
I had a
Again?
little... I say I had a little look for that 1 inch shot earlier. I was trying to get it up on YouTube, but I would
Flat
just
Earth.
struggle to find.
We're proud of our 1 inch.
Yeah.
It's a shame he's not here because we'd just do him a disservice if we kind of just put his images up. You need his
Yeah, fair enough.
his enthusiasm
Mm.
behind them, and the backstory that goes along with them. Really,
Yeah,
I think we'll just do him a disservice.
we'll save that for another day. Yeah, definitely. But you guys are
On every week. I mean, he is by far and away the most hard-working flat earther there is at the moment. He is out daily.
and where is he out daily? What would that channel be there, Nathan?
That's Ranty Flat Earth. No, seriously, you need to subscribe to Ranty because he is really to get these images. And, it gets to the point where you go, the stuff you showed me, and you go, was it yesterday or the day before? That means that there's probably another 200 images that he's got to go through to get back to the ones that you wanted. In the show yesterday or the day before, I said the ones with the with Aries diffraction being shown on a boat and the
Thank
wind
you, Nathan.
behind it, and you've got one wind turbine that, because it's in that band and it's just a pole, you can see that it just looks like a pole all the way down to the bottom, down to the false horizon. Whereas the boat that's in front of it, obviously closer to you, has got this wavy, all that distortion that we see so often. So it's really glaringly obvious with the boat. But when I asked him for it, he was like, I haven't got that picture. I was like, you have shown him. It's really crucial to the point right now. And then about 20 minutes later, he managed to find it. And it was only from 2 or 3 days earlier. But yeah, definitely subscribe to Ranty Flat Earth.
And also, where does he appear generally daily on a channel similar to
Oh, I see.
Nathan Oakley 1980, maybe?
So Nathan Oakley 1980 is where Flat Earth Debate takes place.
Brilliant. And what about you there, Tony? You got your own channel?
Sleeping Warrior.
We know.
Straightforward.
We know. Yeah.
It's all good. But can I just say as well that Ranty's best observations are when he's looking at Barrow in finesse, and he's doing it at 18 miles, a foot off the water, and the water's tidal, and obviously it comes in and out, so he's stood right in front of where the water is. But at 18 miles, that's 2 miles further than Soundly, and we should be getting similar or comparable results, and he can see the shore. So if the Earth is really spherical, and you accept Soundly as the proof, then Ranty should be the same. And Ranty's getting the absolute opposite, and he gets it every single time he goes. All because of the world's not being a sphere.
And so will anyone else who's got the tenacity to go and test it themselves, I imagine.
Yeah.
Well, we've already done him a disservice because he's got one observation, and I will take a small amount of credit for this. So we were discussing some of his Barrow shots, and I said to him, well, when you're taking these shots, you're kind of 90 degrees to your target, and you're a foot off the ground. So the bottom half of the frame, because he's normally got the horizon about center of frame, the bottom half of this frame is representing a foot in elevation between you and the target. You know, you've got this really, really wide angle, and it's filling half the frame. I said, why don't you try and tilt your camera up? So in other words, you're increasing the amount of the lens that you've got to potentially catch that thing. I don't know if it'll make any difference, but it's worth a try. So he a couple of days later went back to the exact same spot, dug out a ditch, I kid you not, and stuck his camera in it right next to the water, and got the shot, caught Barrow from an inch, lifted his camera out to point it where he'd been taking the picture, and literally a second later it was full with water from the tide. It couldn't be any more at sea level. It was an inch above the water, and you could see the waves, because he's in a ditch and it's just lapping up in front of it.
Wow.
You can see higher than the lens. It's just amazing that his camera can get destroyed.
I wonder if you can get one of those waterproof enclosures for the P900 and literally have it in the water. That would be awesome.
I think he's thinking about selling it. It's in really good condition. If anybody's interested.
Have you seen there's a P1000 now, and it's a reality apparently?
Yeah, 125 optical zoom. 4K sensor.
They've got some balls, haven't they, Nickel?
It's not being marketed. Do you know what they're marketing it as? For bird watchers and astronomers, right? They didn't even mention flat earthers.
Oh no, their biggest market, I would imagine.
It's £1,000 though.
Yeah, I'd wait. Well, actually, now is a great time to probably buy the P900.
That's what I was thinking.
Yeah, you think that, but I bet you it goes up in price because nobody can afford £1,000 for a Sunday jolt.
Well, people who spend £1,000 or whatever, or people who bought the P900 to start with, have generally got probably more money than they need. I'm not looking at anyone in particular, but it's those people now that need to sell those P900s to the paupers out there, flat earther like most of us, at a reasonable price, so that they have a deposit for their
a deposit for the next mortgage
for their P1000. Yeah, makes perfect sense.
You see one for sale in the Blackpool area. Tread
it comes free with sand.
Hand me downs. That's what we need.
Cool.
Yeah.
Right, on that note, I'm probably going to do a runner because I've got a new member of the family that I don't want to. Yeah, thanks, mate. I don't want
to. Give a big hug and kiss for me.
I will.
Absolutely. Scratch those ears for me, too.
It's only me, Ant, that's doing one. I'm sure this will go on for a long time after I've done a runner.
Yeah, I'm going to do a runner too, though.
It won't. I'm buggered. I'm off to bed. It's been a good show and a long bloody day. So guys, it was a real pleasure having you on again. Cheers.
Well,
yeah,
absolutely.
Let me just plug someone that's going live now in the next 10 minutes or so.
Oh, go for it, yeah.
Gyroscopes. Make sure you go and watch Gyroscopes because I'm sure he's going to talk about his experiment plan.
Brilliant, I will.
Cool.
Absolutely,
Sorry.
everybody.
Not
No,
experiment. Test.
It's test.
Did you like that, Anthony? When I was getting to you earlier, how I called it a test and didn't say
Yeah,
experiment.
I did. Yeah, we've got to be really careful with that word. It's a trigger word, isn't it?
Yep.
Thank you, gentlemen. It's been a real pleasure.
Yeah,
Thank you guys.
likewise.
For coming.
Likewise. Man.
Appreciate it so
Cheers,
much.
Zach. Cheers, Nathan. Cheers,
Right, well,
everyone.
I'm gonna go and troll the chats in Jaren's channel. So if Jaren goes live, that's where I'm gonna be next for the next half hour or so. So
Alrighty.
thank you guys, and we'll see you again soon.
Thank you guys.
Brilliant.
Absolutely. We need to get you over on TFR again one morning or afternoon or whatever it is for you over there.
Cool, man.
Definitely.
Great show. Cheers, guys. Take it easy. I'm off to go and play
Bust
with
the
my
dog.
pooch. That's not.
Yeah, whatever. You go play with your pooch, John. Off you go.
That's not a. What is it?
Euphemism.
Euphemism. Thank you. Okay. On that note, goodbye.
Bye, man.
Bye.
Love
Bye, Jack.